Okay, so welcome to the Python track of episode 2. Again, this track is not in any way a prerequisite for or a postrequisite for track 9a. This is completely separate, and this is if you want to use the Python programming language to experiment with some of the concepts from the linear algebra stuff, as opposed to the R programming language. So I'm going to be using an environment called Spider. There is also Idle and Eclipse and many other Python integrated development environments, and so it is very possible that the screen that I'm about to show you does not look like your screen, and that the environment that your instructor has given you to work with won't look exactly the same in terms of what the menu options are and where everything's laid out and all that kind of stuff. None of that matters, though. All that really matters is once you're in the window where you're typing a Python program, the syntax that you type and the commands that you type and the structure of your program, all that is going to be the same no matter what environment you use, right? So when you look at this, what you want to do is kind of zone in on the program and then the output of the program and try to kind of not pay too much attention to all the other bells and whistles that Spider gives you, because those will be different bells and whistles than Idle gives you or that Eclipse gives you or that Vim gives you if you're kind of caveman like me and tend to do stuff with an plain old-fashioned text editor rather than one of these fancy schmancy point-and-click interfaces. That being said, this is Spider. And over here is where we're going to write our code in this little editor here. And one of the first things you'll know about Python, or should know, is that you can get Python to ignore a line as basically just meant for human consumption by, among other ways, beginning it with a hashtag sign. So if I say hashtag and I say, getting our feet wet, Stephen and company. This is a way of telling Python, please just ignore these lines here, Python. This isn't Python code I want you to actually do anything with. This is just so I can insert some notes for myself. And it's very useful to do that for two reasons. One, you can actually narrate your program and explain some of the more complex things that are going on, and you can kind of get some English notes from it. Also, it's very important because there will be times when you're writing a bunch of code and you sort of temporarily want to disable parts of it from running. And the way you can do that is insert or prefix a little hashtag before the lines that you want to not run right now, and you've sort of temporarily put those out of commission, and then you can comment them back in later. So commenting out a line of code is the word used for putting a hashtag at the beginning of a line, and then uncommenting it out is when you take that away, and then it's actually Python code which will be executed by the Python interpreter. That would never happen with our getting our feet wet thing, because that's permanently meant to be a comment, but it will happen with other lines of code. Okay, so the basic building block of any program, and if you've done computer programming in Python or any language, this will be very, very natural to you. If you haven't, though, it's a little new, and that is simply the notion of a variable. And a variable is just a named thing, just like in math, where we can say, I'm going to set x equal to 5. And what you're doing there is you're saying, I would like to create a new storage location, essentially, and I want to put the number 5 into that storage location. So it's kind of like in math when we say x equals 5. One difference is that if later on in the program we say x equals 7 or x equals 8, that overrides the previous value, and the previous value is lost. So in math, you would never say x equals 5 and x equals 8. I mean, that wouldn't make any sense, right? How can a number be 5 and also 8? Well, a program happens sequentially. So when this thing runs, all of the lines in order are going to get executed. And whichever one comes last is going to win in the sense that it's going to overwrite the previous lines, okay? So when I run this thing by pressing the little run button, it runs, and then down here on my console, I can sort of see what happened. I can say, hey, what's x anyway? And sure enough, it tells me 8. And you can sort of ignore all these little in, out, to things, and all the other gibberish that's on the screen. That is occasionally useful when you know what you're doing with programming, but the primary area of display here is just what it prints right there, and it tells us that x has the value 8. And in this window, if I say, hey, x equals 9, then I can say, hey, what's x? And it says 9. I can even do something like x equals x plus 1. Now that is a nonsensical math statement, right? I dare you to find any number where it's true that x equals x plus 1. Okay, don't strain because you won't find one. But that actually is meaningful in a programming language, because what this is really saying is not x equals x plus 1. This is really an imperative mood statement saying set x equal to x plus 1. And so when I do that and I say what's x, it's equal to 10. because it basically said take x, add 1 to it, and then put the result back into x, such that x is now changed with its updated value. You will see that all the time in programming languages. All right? Now, a few things, and then just sort of some bookkeeping here, and then we'll get to the actual Python stuff, right? So, by the way, in Python, you can type stuff in your program. You can also type stuff directly in the console. I'm going to be doing a lot of the latter in this lesson simply because we're not going to be doing anything that complicated, and it's a little just quicker to do stuff on the fly. But normally, if you're writing a program of any substance, you're going to want to put it all up here so that you can continually run it and refine it and debug it and run it again, and then you have it as sort of a record of what your program is at the end, rather than it simply being a temporary, transient type of thing. So in Python, you can do some operations that are pretty obvious, like if I say x plus 2, that's how you do addition, right? I can say, what's 3 plus 4, and it's going to say 7. I can say x minus 5, and it says 5, because remember, x is 10 still. That's something worth noting, by the way, if you're not used to programming. When I say x plus 2, that gives us the number 12, but that did not change x to be 12, right? In order to change x to be 12, because right now it's still 10, I would have to say x equals x plus 2. And then it would verily change x to be 12, right? But just saying x plus 2 is basically saying, hey, just give me the result, x equals, or give me the result of whatever x plus 2 is, right? In Python, the way we multiply is we use a splat key. So if we say x splat 2, that's how we multiply. So x times 2 is 24, obviously. The way we divide is we say slash. So if you say x slash 2, it tells me it's 6.0. And that's because, if you divide something by 2, it may or may not be a round integer whole number anymore. It may be a decimal number, and so it's gone ahead and proactively changed that to a decimal number there. The way you do powers is you use a double splat. So if I say x squared, that's 144, because x is 12, right? And of course I can combine these. I can say, hey, what's x minus 3 squared plus 5? And the answer is 86, because x is 12, and x minus 3 is 9, and 9 squared is 81, and 81 plus 5 is 86, right? So that's just kind of your general math stuff. You can also do things like, what's the square root of 81? And I lied, you can't do that. How do you do square root in Python? I'll have to look that up. Evidently it's not square root. Oh, no, I know what it is. I know exactly what it is. Right, okay, so this is, pardon me because I'm not a Python guy, I'm an R guy. Right, so this is a key line of code that you're going to want to put on the top of every one of your Python programs. And I'm actually going to put a cheat sheet up that has the common commands for this so that you won't have to remember all these things. You can freely look at it. You're going to want to say from numpy, or numpy, it's pronounced both ways, import splat. Okay. Now, it gave me a little thing here. It says invalid syntax. I'm not sure why it's saying that, because if I run this, clearly that's not invalid syntax. And now if I say square root of 81, now it says 9. Okay. And that's because square root, this was in the numpy package. So let me just back up for a second and say that one of the things we're going to be using all through this course in Python is the NumPy library, which is a very powerful package for doing scientific programming, linear algebra, and other things in the Python language. Unlike R, Python doesn't come with all the linear algebra stuff automatically. You have to load it in a separate package, and that's why when we say from NumPy import splat, that's geek speak for, I'd like to use things in the NumPy package, please, including the square root command. And so that's why we had to do that. So you probably want to get in the habit, just for this course, of the very first thing you do when you start a Python file is right away you say from NumPy import splat at the top, so you can use all the stuff that we're going to be using in here. All right? All right, back to work. One of the things that's going to be the most important thing that we do in this course, because we're doing linear algebra stuff, is to make vectors, right? So the way you make a scalar is just what we've been doing, x equals 5 or something like that. But if I want to make a vector, here's how I do it. I say x equals array, banana, boxy, and then I list the elements of the array separated by commas. So if I want to make a vector that has 4, 2, 5, and -6 in it, that's how I do it. And if I want to say, hey, what is the value of x, I say print banana x banana. And then it says, your vector has those elements in it. And isn't that nice? I can make another one. I can say y equals array. And I'll set that equal to 1, 1, 1, 1, boxy banana. And then I can say print y. And I get that thing right there. Let's test our different vector operations. So we know we can do scalar multiplication. So let's say print 2 times y. And we get all 2's. And that's because, remember, when you do a scalar multiplied by a vector, you get back a vector where each element of the vector has been multiplied by the scalar. If I say print 3 times x, I'm going to get 12, 6, 15, negative 18, because that has taken each of the elements of x and multiplied each one by the scalar 3. Let's do our vector addition here, print x plus y, and we're going to get 5, 3, 6, 5, because remember, x is that, and y is that. By the way, if you just type x, it prints it out like this, array, which is fine. You can tell what's going on for this small example. Usually, though, for something bigger, you want it to print it in a more readable way, and you can do that by the print command. So, at any rate, x right now is equal to 4, 2, 5, negative 6, and y is equal to all 1's, and so when I add them, that's obviously what I get. And if I say print x minus y, it does the obvious thing, subtracting 1 from each element of x. If I say print x minus x, I'm obviously going to get all 0's. So all that works as we thought. If I make another z here, and I say make that equal to 3, 4, 5, if I say print x plus z, it's going to blow chunks, and it blows chunks because x and z are not the same length, right? You cannot add 2 vectors unless they're the same dimension. And z is 3-dimensional, y is 4-dimensional, that's why I couldn't do it. And that's what this says in geek speak. It says, could not be broadcast, these operands together with shapes, blah, blah, blah. It's nerdy way of saying you've got two vectors that are not the same dimension, dork, and so you can't add them together like that. Same thing is true of dot product. Now, the way you do dot product is different than you might think, right? So you'd think that x times y would give you the dot product, but actually no. X times y does the thing that you might have thought multiplication does, which is, multiply each element of x times each element of y, right? So y is all 1's right now. Let's make that maybe a little bit more interesting. Let's make it 1, 2, 3, 4. And now let's say print x times y. It's going to take every element of x and multiply it by every element of y, right? So it takes the 4, multiplies it by 1, takes the 2, multiplies it by 2. So we got 4 for the first 2 elements there. Then it takes 3 multiplied by 5 gets you 15, etc. Right? So this is what, before Stephen blew your mind with the dot product thing, that's what you thought times would have done in programming languages, as I mentioned at the time. Do this because there's shorthand times when you sort of need to do that, kind of as a little bookkeeping measure. But the important thing is to be able to do dot product, which you do like this in Python rather. You're going to say x dot, and then you're going to say y. And when you do that, you get -1 in this case, and that's because x is that and y is that. And if you take 4 times 1, you get 4. If you take 2 times 2, you get 4. If you take 5 times 3, you get 15. So adding all those up gets you 15 plus 4 plus 4. Quick, hey, I have Python at my disposal. What is 15 plus 4 plus 4? 23, great. And then -6 times 4 is going to be -24. So the whole thing is going to give you 23 plus -24, which sure enough is -1. Okay, so you got to remember it's kind of a weird syntax, right? You'd think you might say something like x dot y. After all, it's the dot product. But no, you say dot y. And there's a lot of things actually that we're going to see that have the dot and then some kind of word after it. We'll see some more examples of that in a minute. Let me tell you some other ways to make vectors, which will turn out to be useful. Right now we've seen that, you can list the elements, say how I want 1, 3, 4, 5, and make it that way. You can also say, hey, I want a vector of all zeros. That turns out to be very useful sometimes if you want to have a cumulative total and you want to start a bunch of things out at 0. So I can say zeros, and make me 11 of those. Heck, print z. And now I've got a vector with 11 zeros in it. You can also use this rather nutty function called arange. And arange you kind of got to get used to this. If you haven't programmed, this will seem strange to you, but if you have, it might not seem as strange. So let's make something called weird. And by the way, variables can have more than one letter in them. The only ones I've used so far have been X, Y, and Z, but you can name it anything you want, and normally you want to name it something descriptive. Not that weird is that descriptive, but do name your variables with something that actually indicates what they are representing. Don't just call them all X and Y, because then you'll quickly forget what they actually mean. Anyway, if I say weird is a range 7, and then I print that, what it does is it gives me a list, a sequence of numbers here. Now, sort of weirdly, which is why I called it weird, it numbers them starting with 0, and then it gives you 7 of them. So that's why that goes from 0 to 6. So sometimes, Python seems a little odd. Oops, I don't know what I just clicked on there. Sorry about that. Python seems a little strange because it starts everything indexed at 0, and we humans tend to be used to indexing at 1. You just got to get used to that. You could, of course, always say, hey, what's weird plus 1? And if I say, hey, set weird equal to weird plus 1, then if I print weird, now it is, as I might have thought, starting with 1 and ending with 7, right? So you can kind of get around that thing. Another thing you can do in Python is you can say a range, and you can give it 2 different things separated by a comma. So I could give it 1 and 8. Okay, so if I do that, it is actually going to go from 1 to 7. So this basically says what number do I want to start with in my sequence, and then I'm saying how many I want minus 1. So it's really weird how you tell it 8, but that doesn't mean you want 8 things. It means you want 7 things. So. Or I'm sorry, no, it doesn't mean you want 7 things. It means you want to go up to this number minus 1. So if I say, hey, what's a range of 3 to 8? It says, oh, well, I'm going to go from 3 all the way up to 1 shy of 8. And there's some sensible reasons that it does that. I personally find it annoying, but you just kind of got to get used to that if you're using Python. That if you want something to go from 4 to 10, you don't say a range for 10. You say a range for 11, and then you'll see something going from 4 to 10, right? By the way, just a little lingo here, and you'll hear me use these terms a lot, so you do need to kind of understand this. This here is a command. More often, though, I'm going to use the term function for this. And if you've taken all the math, volume 1, you may have remembered there's a mathematical thing called a function. And that's really actually what this is in a programming sense. And these 2 things here, it's kind of a weird word. We call these things, the 4 and the 11, we call them arguments. Sometimes they're called parameters, but more often they're called arguments. And so let me give you a sentence here, and this is a really good sentence to know. What I'm doing on this line right here is I am calling, that's what we do, we say calling. We are calling the function a range, and we are passing it the arguments 4 and 11. Okay, so there's 4 special words here: call, function, pass, and arguments. Non-computer scientists never use any of those words in this way, but those are all used in a very specific way by computer scientists, and I'm always going to say that. I'm going to say, hey, let's call this function and pass it these arguments. And the arguments that you give it are always separated by commas here. All right, fun fact. One last thing you can do with a range is I can say a range something like, I'm going to go from 5 to 50, okay, but I want to go by 5s. So this goes 5, 10, 15, 20, 25, 30, all the way up to 50, not 50, but 1 item shy of 50. Remember, just like it didn't go up to 8 here, it went 1 shy of 8. Here, we're not going up to 11, we're going 1 shy of 11. Here, we're not going up to 50, we're going 1 element shy of 50, and we're going by 5s. So sometimes that's useful because you want to have some sequence of things that goes up by a number other than 1. And you can specify that in your A-range thing, right? All right, a few more things here. Sometimes it's useful to get random numbers. So I might want to say, let me get 5 random numbers. And if I do that, it gives me back a vector, which has 5 numbers, all of which go from 0 to 1. Okay. Now you might say, well, what if I want a different range? What if I want them to go from 0 to 100? Well, there's ways to do that. A simple way to do that is simply to get that thing and then do our scalar multiplication of it, right? And that is going to take each of the random numbers, which goes from 0 to 1, and multiply each of them by 100, and that effectively gives us a bunch of random numbers that go from 0 to 100, right? Maybe I want integers. Like, let's say I want to play Yahtzee, and I want to roll dice, okay? So what I want is something like this. I want it to go like from 1 to 6, right? So this is going to give me numbers from 0 to 6. Now, one thing I can do in Python is I can say I want to trunk. Okay, so I want to truncate these numbers. What that means is round down. So that says take each number that I get and just round it down to the nearest integer. That's different, by the way, than the round function, which doesn't round down, it rounds, oh, that's right, I forgot this about Python. It's round underscore. For whatever reason, you have to say round underscore. So if I do that, it's actually going to be rounding to the nearest integer up or down. So we can see that if we don't do random here. Let's do round underscore. And let's get an array, and we'll put in here 4.4, 5.4, 5.6, 8.9. So if I do that, then I'm going to get back 4, so it rounded the 4.4 down to 4, and then it rounded the 5.4 down to 5, it rounded the 5.6 up to 6, and it rounded the 8.9 up to 9. Okay, so round actually moves it to the closest integer, which is different, as I mentioned, than truncate, which is going to do this. If I can get this to work. There. This is going to make it 4.558, right? Because this 5.6 gets truncated all the way down to 5, right? All right, so back to our dice thing. So if we said let's truncate it, that would work, except that's going to give us numbers between 0 and 5. And of course, there's not a 0 on a die. So really what we ought to do is add 1 to that. And now we're going to get, every time we run this, a die roll in Yahtzee where 5 dice are rolled and each one has a value of 1 through 6. Okay, fun stuff. A few other things here you can do with arrays. If I have an array like x, I could say x dot size. So that's another example of the dot thing, which does not mean dot product at all. It just means that we're accessing a property of the x object is really what it means in computer lingo. So that'll tell you the size of that thing, right? So I could say, you know, what if I'm going to do an A range here, and I want to go from 5 to 1002 by 13s. Hey, what is its size? And it says, that thing's going to be 77 long if you do it. Okay, so I've combined two operations here. Here I've said make a vector that goes from 5 to 1002 by 13s, and then dot size it, which means tell me how many elements are in it. Another thing we can do is we can rip individual elements out of a vector, right? So we know that x looks like this. So I can say, hey, what's x of 3? And that is -6. So remember, Python indexes its vectors by 0, starting with 0. So if I say, what's x of 0, it tells me that's a 4. If I say, what's x of 1, it tells me that's a 2. If I say x of 3, it tells me that's a -6, right? So you got to get used to the starting with 0 thing, because that is ubiquitous throughout Python. Another thing I can do is I can say, hey, I'd like x of, get this, 1:3. Now, what that should mean, in my opinion, is give me elements 1 through 3 of the vector. But of course it doesn't. It gets elements 1 through 2 of the vector because, again, this upper one here isn't where you stop. It's one past where you stop. Okay, so if I say let's make a vector here. Let's do the random thing. So we're going to say random.rand, and let's make it 10 long, right? Okay, so z looks like this here. So if I say, what is z of 3:7, then what that's going to give me is elements number 3. So this is 0, 1, 2, 3. So my first element was 0.03. Element number 4, which was 0.976. Element number 5, which is 0.98. Element number 6, which is 0.729. And then element 7, but not element 7, because Python is weird, and this doesn't mean where you stop. It means one past the way you stop. All right? So that's occasionally a useful thing to do, to rip part of a vector out. All right? So we've done dot product, and we've done scalar multiplication. We've done most of the little vector operations, which are going to be on the cheat sheet, which I will post. An important one, obviously, is the norm. So let's do that. So here was our x, right? So the way you do a norm is you say lin_alg.norm, and you give it x in the bananas. So this is another example of one of these things where we're calling a function called norm, and we're giving it the argument of the vector we want to take the norm of. So if we hit enter here, that's 9. Now why is it 9? Well, because Python by default does the Euclidean norm, right? Which is what I told you. The L2 norm is sort of the default one, right? And we can do this ourselves manually. We can say, hey, what is the square root of 4 squared plus 2 squared plus 5 squared plus negative 6 squared, right? Because that, after all, is what this means. When we do the Euclidean norm, we're taking each of the elements of the vector, squaring it, adding them all up, and taking the square root, right? So what is the answer to that? The answer is 9. And so, yay, verily, this did in fact compute the norm correctly, as we knew it would. Why would I use norm if I can just type this? Well, you can do either one. Norm is just shorter, is basically the reason, right? I can also say norm, and I can say ord equals 0, and that says please compute the L0 norm, which you will recall means the number of non-zero elements in the vector. And this vector has 4 elements, none of which are 0, and so it comes back and gives me a 4, right? If I wanted to change 1 to 0, just to kind of look at that, so if I say x of 1 equals 0, and now look at x, you've seen that I've now replaced this with a 0 here, right? And now if I say, hey, what is the 0 norm of the thing, it's going to say 3, because there's only 3 non-zero entries. I can take the 1 norm, which remember is the taxi cab or Manhattan norm, and that's going to say that's 15, because if you add these all up, you get 15. Remember, adding up means adding up the absolute values, because we have to go 4 in this direction, we have to go 5 in this direction, we got to go 6 in this direction. Doesn't matter if we go north or south through Manhattan, it's still 6 blocks. And so it's going to give us that thing here. And then finally, we can say ord equals inf, like that. And that gives us 6. Remember, the infinity norm is simply the maximum in absolute value, which turns out to be 6 in this case, right? So most of that was pretty contrived data. We're just making up a bunch of variables that have no meaning, like x, y, z, and weird. Okay, let's make this a little bit more useful. And go back to the matchmaker example that we looked at before, right? So remember, I was mentioning there that we were going to normalize the vectors in order to prevent Jezebel from cheating, right? So Jezebel is saying, hey, you know, if I want to be first in line for all the guys, I can basically leapfrog over Cindy or Sue or whoever else is in this matchmaker thing by simply answering all the questions with a 10. Because that's going to give you the maximum dot product with any guy, right? Because you can't get any better than that. So what we're going to do is say, look, here's the deal, Jezebel. We're going to take your vector and every other person's in matchmaker.com, and we're going to normalize it to be the same magnitude, the same size, the same length, the same norm, right? So that if you say all 10s, all that really means is you are equal in all the questions. And if some other person is equal in all the questions, they're going to appear very like you. And if they're not equal in all the questions, they're not. But you're not going to get this built-in advantage just by putting 10s everywhere, because we're going to scale that down. All right, so let's see what that looks like. So over here to our program window, because this is kind of something where we want to have something bigger, right? So let's make Jezebel, and let's make her an array with, so this is a vector, and we're going to say, hey, 10, 10, 10, 10, 10. We'll say there's 5 survey questions. Let's make another person here. Let's say Cindy is actually taking the survey seriously, and she's saying, well, you know, on a scale of 1 to 10, how much do I like tuna fish? Well, that's a 3. How much do I like fly fishing? That's a 3. Or 4. How much do I like, you know, walking in the outdoors? Well, that is high, actually. How much do I like camping? Not at all. And how much do I like knitting or crafty things? Well, we'll say that's an 8. Okay, so she's actually taken the survey seriously and answered those things. All right, let's put some guys in here. Let's say here's Biff. And Biff answers, you know, 9, 7, 4, 5, 2, something like that, 3. And we're going to say there's Joe. And maybe Joe adds or says 0, 10, 0, 10, 0. And then we're going to say Filbert, and Filbert is going to have values 3, 4, 10, 1, 8. Okay. Now, I deliberately chose this, and you may be able to see, I tried to make Filbert the dream match for Cindy, right? Because Filbert is very, very close to Cindy here. In fact, the first 2 questions on the survey, they answered exactly the same. The third and fourth, they were only 1 off from each other. And then the last one, they answered the same, right? So clearly, Filbert is more similar to Cindy than he is to Jezebel. Yet Jezebel, until we normalize the vectors, is going to be able to steal Filbert away, right? Because look, if I run this thing, and now I come down here and I say, what is Jezebel dot Filbert? Well, that's 260, man. Heck, that totally kicks the butt of Cindy. Because Cindy dot Filbert's only 179. So if my matchmaker let Jezebel get away with it here, we're going to end up having Jezebel be the best match with everybody, right? Heck, Jezebel matching with Biff, that's going to be high too. And matching with Joe, that's going to be high too, right? By the way I'm doing this in Spider, and many environments work this way, is I'm pressing the up arrow here, and when I press the up arrow or the down arrow, it cycles back through previous commands, so that can save you some typing, because you can kind of go up to a previous command and then edit it by using the arrow keys. So a little tip there. All right, so here's what we're going to do. I'm going to say Jezebel equals Jezebel divided by her norm, right? So we got to do linalg.norm, and we're going to say Jezebel, and we're going to say order equals 2, or actually we don't even have to say that because the default is 2, but I'll just be explicit just for fun here. So again, if you haven't done programming before, this line looks a little weird because you've got Jezebel on the left-hand side and you've got Jezebel on the right-hand side, and it looks like we're making an assertion that Jezebel is in fact equal to Jezebel divided by her norm, which of course isn't going to be true unless she ended up normalized to begin with. But that's not what this is saying. This is actually an imperative mood statement saying, hey Python, please set Jezebel to be herself divided by her norm. Okay, so we're using Jezebel twice on the right-hand side of this equal sign in order to compute the normalization equation, and then we're setting Jezebel equal to that there. So if we run this now, and we say, hey, what is Jezebel? We're going to see that now she is 0.447 for all of these different things. And that is simply because that is the value she needed to have in order to have a norm of 1, right? So again, if we take the norm of Jezebel now, linear algebra.norm, she's going to have a norm of 1.0, right? Because we have normalized her, duh. And so basically what we're saying is that Jezebel, when she did this, really she wasn't saying, hey, I'm awesome and powerful in all 5. She was basically just saying I'm equal in all 5, right? So she's going to come up very close to someone who has equal values in all 5, even if they're not all 10s, right? If we have some guy down here, his name's David, and we say, he's kind of a pessimistic guy and he just answered 2 to everything, that's somebody that Jezebel is going to end up being very, very close to in the normalized scenario. Right? But she's not going to be close to Biff because he's all over the map, right? And Joe particularly not close to because Joe is very, very different in these other things, right? Okay, so let's normalize everybody. And I actually don't know any easier way of doing this than just a bunch of copy-paste. Maybe there is an easier way. My editor that I use on a day-to-day basis is called Vim, and I could do this whole thing in about 1 second with an advanced command. But here I'm just going to paste and paste and paste. This isn't too bad. Joe, we're going to do Joe, and we're going to do Filbert, and we're going to do Filbert, and then we're going to do David. Okay, great. So, run this puppy. And now we'll see that everybody is normalized, right? So Cindy looks like that, and Biff looks like that. Let's look at Joe. I think that'd be illustrative. So Joe does have 0 for questions 1, 3, and 5, but he's got 0.707 for these middle 2. So again, we've sort of made them all a constant average, so to speak, and we've just represented them in terms of which one is relatively bigger than the same the other elements in the same vector, right? Okay, so now, the coup de grace here, if we say, hey, what is the dot product of Jezebel and Filbert now she gets a 0.84 Whereas, I can tell you right now that Cindy's going to do better with Filbert. They are a match made in heaven, man, 0.9959, because the maximum you can get is 1 when you have two normalized vectors, right? Because the maximum you're going to get is two vectors of length 1 that are perfectly aligned. Then you're going to end up getting cosine of 0, which is 1, so you end up getting 1, right? And if we say, how does Jezebel do with somebody like Joe? That's pretty low, 0.63, because Joe is, really high in some, really low in the others. He's not at all, similar, whereas Jezebel is going to do quite well with David. In fact, they have a perfect match because Jezebel answered the same thing to all of them, and David answered the same thing to all of them as well, right? So just a little bit getting our feet wet there with Python. One of the things you'll learn if you haven't done programming before is that there is no forgiveness with the syntax. So you'll learn that Python is extremely anal, as every programming language is, with exactly how you type the characters. So, you cannot say, those bananas sort of look too smooth. I'm going to use angle brackets or I'm going to use boxies or something like that. Won't work. If you don't like ... and you want to just say dot, won't work, right? You have to do everything, color inside the lines just like I told you, and then it will go well with you there, right? All right, one last thing, and that is that one of the things we're often going to do when we work with data is we are going to want to load things from a file. So I'm going to say open a file here, and I just so happen to have a file that has some information from... let's see, I guess I need to say all files or something. Yeah. I want to look at the Fredericksburg.txt file. So I made a file that looks like this. Now, again, don't get the feeling that because I opened it in Spider here that this is somehow a Python file. This is not a Python file. This is just a plain old text file. And I have simply put the high temperatures that we've had here in Fredericksburg over the past few weeks. So 3 weeks ago or so, we had some nice days that had the high in the 70s and low 80s. Then we had a heat wave recently. Now it's kind of calmed down a little bit. And often, the data that you get and that you look up is going to be in files like that. You're certainly not going to type literally into your Python program a million-line vector. So the question is, how do we get this into Python? And the answer is it's very easy as long as this is formatted reasonably. And what you do is this. You say load txt. And if you say load txt, what that's going to do is return a vector. So maybe I'll call this weather, and I'll set that equal to load txt. And then you have to give it the file name. Now, this is the one part that messes up a lot of students because I've discovered that this latest generation of humans has sometimes trouble figuring out how things are laid out in their file system. So on my computer here, I happen to know that this file is in /home/Steven/125/Fredericksburg.txt. So this is known as a directory or a folder hierarchy, and this is basically how I've organized my files on my disk, and so this is telling you the path to it. If you're doing this on Windows, probably you're going to start out with something like C:\\\documents and settings /something. I'm not exactly sure what that's going to be, but what you need to learn how to do is open up the File Explorer or whatever it's called in Windows or Mac and kind of figure out what the names of all the folders are and what's inside of what so that you can specify the path to the file. And once I do that here, then I can say, hey, what's weather? And it is, in fact, an array, just like all the other NumPy things that we've done. And if I say print weather, it just prints it out just like this. And then I can do things like say, I can say, hey, what's the weather .min? So that's a function that gives me the lowest value in a vector. So that's 72. And if I say, hey, what was the highest temperature we've had? Oh, well, that was 96. I can say, what's the sum of the elements, and then divide that by weather.size, right? And that'll give me an average temperature, which is 84.4. And you can do all kinds of other things with that here, right? So bottom line is that you can do all kinds of analysis and stuff, and we will be doing some examples like that in this course. Once you've got the thing into Python or into R or whatever your programming environment is, and load txt is a very simple way to basically load a bunch of things into a vector. All right, thanks for tuning in. I hope you learned a lot in episode 2. I will catch you next time on All the Math for episode 3 when we look at linear independence.